Good morning, friends. After meter base, one more apparatus is there, popularly known as potentiometer, right? Based on this, we have got two experiments in class 12. So it is a topic which is related to not only to your theory class but to practical also, right? Itself it is saying potentiometer, meter, a device which can measure the potential, right? A device with the help of which one can measure the EMF of an unknown cell. Second, compare I could say the EMFs of the cell. And third one is to find the internal resistance of an unknown cell. These three practicals are there based on this device, potentiometer, right? Now question arises, what is it and how does it function and what is the principle behind it? So far as basic principle is concerned, it was based on, we used to say, Bull's principle, though it is not a scientific one, Bull's principle. In tug of war, suppose I am having a ball in this side B1 and one here as B2, tug of war. So what will happen? If B1 is greater than B2, the tug will move towards B1. If B1 is less than B2, the tug will move towards B2. And if B1 equal to B2, right? This is known as equilibrium condition. This is tug will move towards B2 and first case towards B1. Keeping this in view, instead of bull, if we apply two cells of different EMF, let it be E1 and I am connecting a galvano here and E2, the second cell, right? Now, in this case, instead of making a block diagram, if I make it like this, that will be better. E2 and E1. Opposite equation they applied to a galvano. Here, in this practical situation, if E1 is greater than E2, then galvano will show a deflection towards E1, due to E1. If E1 is less than E2, then deflection will be towards E2. But if E1 is just equal to E2, then no deflection will be there. No deflection will be there. So this concept is used. If I apply a cell, a known cell and an unknown cell, and we will try to find out a null point position when both are comes out to be equal, then the value of this E2 becomes just to E1. Now how to adjust this device, how to form it? It consists of a wooden block having a very large number of large turns, you could say. Generally in lab we have got 10 meter wire potentiometer, but it is not necessary. This is a wooden box on which this wire is fitted. This terminal A, this is B, and these are the wires. It is a wire made up of constant or manganese. These are the alloy, right? Alloy whose temperature coefficient of resistance is very small. They are almost independent on temperature, right? What we do, we apply a known circuit to this. This we call known circuit because here we know the applied EMF. This is the known EMF, known cell. Right? With this cell, we apply a rheostat. I will talk it later on. Rheostat, RH we call it. And this rheostat is connected to an ammeter. Right? And an unknown cell is applied here. This is the unknown one, which is connected to galvano, and galvano is connected to a jockey. This is the basic circuit diagram of potentiometer. Before starting it, we will try to find out what is the working principle. Working principle. This is the actual principle on which this is based. Working principle of potentiometer. So this principle is originated from Ohm's law. If you do remember, according to Ohm's law, what we were having, V equal to IR. If I have one out I is nothing but rho L by I. By this we can have I rho by into A into L. Right? If I is constant current is passed through it, right? A uniform area of cross section, rho resistivity of the metal of the wire, right? If you satisfy these three conditions, that I is constant, A is uniform, and rho is the resistivity, then what will happen? Then V will become directly proportional to L, right? Or you say it V equal to KL, where this K is known as potential gradient. Now, what should be the statement of this potentiometer? What it is saying, if a constant current is passed through a wire of unit area of cross section, then the potential drop across any length of that wire is always directly proportional to that length. It is very important, so I am going to write it down. What this principle says that if constant current is passed through a wire of uniform area of cross section, then the potential drop across any length of that wire is directly proportional to that length. This is known as working principle. V directly proportional to L if I and A are constant, or V equal to KL. Right? So this is the basic principle of potentiometer on which it is working, where K is V via L. We define it potential drop per unit length of a potentiometer, and it is known as a very popular quantity, potential gradient. Right? We got K equal to V via L. Right? Remember this practically, smaller be the value of K, higher will be its sensitivity. So sensitivity K equal to V by L. So smaller be the value of K, higher will be the sensitivity of a potentiometer. That's why we use a long wire potentiometer. In our lab mostly we have got 10 meter wire potentiometer, right, just to increase the sensitivity, right? And so far as unit is concerned, it is volt per meter or per centimeter. For example, if I am having an unknown cell, a cell of EMF 3 volt, and its total length is 10 meter, or 10 into, or I could say 10 to the power 3, I will make it, just to clear it, centimeter. In that case, K will be V via L, 3 via 10 to the power 3, or 3 into 10 to the power minus 3 volt per centimeter will become its sensitivity, the potential gradient, right? After this working principle, let us start with the practical part of this, how to use this potentiometer. I have applied a circuit here. This is known cell, this is rheostat, this is ammeter, right? And point here, an unknown cell of EMF, let it be E, is applied here, right? Now what is happening? Before starting this experiment, remember, a potentiometer is a current based device. Current based device, sometimes they do ask, right? That's why we use the meter in order to make a constant flow of electric current, right? One more thing, if you could see, repeatedly I'm saying rheostat. We denote it with RH. Its symbol is like this. Right? Now, what is rheostat? Remember, it is a variable resistor. What is there? In which, if you will see the lab, you will find that black type cylindrical box is there, like this, right? This wire is made of, or known as oxidized nichrome wire. Why oxidized? Just to insulate the system, right? And it has generally got 3 terminals, 1, 2 and 3. Right? We name it A, B and C, like this. And you could find the rod is there and a slider. Some sort of diagram you will find, slide, right? It is a variable resistor made up of what? In which oxidized nichrome wire is wrapped on a china clay. This is china clay pot. Right? Again I am repeating, oxidized nichrome wire. Why? Because just to insulate the system, the wire, it is oxidized. Nichrome has got low temperature coefficient, again high resistivity, and it is wrapped on china clay. So this rheostat can be used as a current divider or as a voltage divider. Here in experiment we use it as a current divider, right? Like this I have shown. One terminal will be here, another will be here, Rx. It will be used as a current divider by varying the resistance. Right? Now how to use it? Now, this circuit is known as known circuit, this part of the circuit. Known circuit, and this is the unknown one of which we are trying to calculate. Right? With the help of this known circuit, we supply a constant current, I remember, small current in the circuit. What will happen? That will produce the potential difference across this wire, as it is going to flow everywhere, right? In order to apply that Boole's principle, what we do? We apply the unknown cell just opposite to the known one. Look at this circuit. Both the positive terminal are connected to a point A. They are opposite each other. So what happens? First we will try to calculate the potential gradient of the circuit. E is the known EMF, you could say. The cell, right? E, generally we used to say I into R plus R, right? This R sometimes consists of R external, if we are applying external resistance, plus resistance of the wire. Remember this fact. This wire AB will have its own resistance. R external plus resistance of AB. Generally it is always given there that the resistance per unit length is this much. Right? So that gives you the current I equal to E by R external if it is applied plus resistance of the wire plus internal resistance. That gives you the current through the system. Right? Now if I am applying this unknown cell E dash opposite to it, what will happen? First of all, with the help of this jockey, we will try to check the continuity. This is the foremost part, right, of any experiment. Continuity. How to check the continuity? Once the circuit is established, what we do? Tap at A point with the help of jockey. The galvano will show a deflection. So, tapping at B, remember this is key factor, the galvano must show a deflection in the opposite direction. This is very important point of this practical. That's how we check the continuity. Tap the jockey at A. This is the jockey. It will show a deflection in particular direction, either in an LHS direction or RHS direction. When you tap it at B, it will show a deflection in the opposite direction. If it is so, means continuity does hold, means our system is ready for the practical. If not, then something is wrong in the circuit. So most of the time what we got while dealing with this practical, either your unknown cell is not working or the EMF of the known cell is less than the known one. Then it gives you only one side deflection. Remember these two key factors. Unknown cell is not proper. Whatever you have made, whether it is Leclancy or Daniel, its voltage is not proper. This is one of the reasons. Another reason is that if the EMF of the known cell is less than the unknown one, even then it will show one side deflection. Be careful while making this arrangement. With the help of voltmeter, do measure the EMF. Make sure that known EMF is greater than the unknown one or somewhere equal to, but always greater than that. Right? Then and only then you can perform this experiment. Once the continuity is established, it is very easy how to find out the EMF of an unknown cell. Right? First, calculate K. Right? V via L. That is the total potential difference via total length. First calculate this. Right? With the help of jockey, what is happening? At A it is showing a deflection in purple direction, at B opposite to that. We will try to find out. Try to find a point C at which galvano shows no deflection. That is equilibrium position. What will happen in this position? In this position, the potential drop across AC, this point to this length, right, will be just equal to the EMF of the unknown cell, right? Because it is being balanced by this length. In this condition, the EMF of this unknown cell will be just equal to the potential drop across AC. Yani, if I want to calculate the unknown as E dash will be what? It is saying VAC. What will be VAC? According to principle of potentiometer, it will be KLAC. This will give you the value of unknown EMF. One practical problem will come out how to measure AC. Remember, in the meter base, we will have a two-sided scale on this wooden block. One is starting with 0 to 100, that is left to right, and other will be starting from 0 to 100, right to left. The left to right is for odd number of wire. Odd number of wire, that is 1, 3, 5, 7, 9. If I am having 10 meter wire, I could say 1, 3, 5, 7 and 9 wires. I will read the scale from left to right. This is for even number of wires. The null point is on the even number, that is 2, 4, 6, 8 and 10. We will measure the scale from where? Right to left. For odd, we will measure from left to right. Right? Suppose my null point is on 5th wire. Right? 5th wire. What is 5? It is odd. Right? So I will read from left to right. Let it be this point. Suppose this is the point C. Right? And it is measuring 27 centimeter. So what will be the LAC now? 5th wire means 400 are already completed plus 27. That will become 427 centimeter. Is that? Now, if the same way, if the deflection, if the null point is on 8th wire, so what is 8? It is an even number, so we will read it from right to left. Suppose this is the value here, it is C, measuring 52. Right? So what will be my reading? In this case, LAC will be 8th wire means 700 we have already completed, and while coming from right to left, it is showing 52 centimeter. It will be 752. That's how we have to read the reading. Remember, we will start, if I am connecting positive terminal at A, my starting point will be A. Right? In some practical book, they start from here, but their starting point will be this. So be careful. Use this one which we are using, right? And very easily one can calculate. This is the basic experiment. Now, what is the main experiment in our 12th syllabi is to compare the EMF of two unknown battery or cell by using this potentiometer. Easy concept now. While doing potentiometer, remember we have to use that Bull's principle. Means battery should be applied opposite to each. So what I am doing, this is the known cell, known circuit. We are not going to vary. Now we have, instead of one, we are having two cells. One, second. Suppose this is Daniel and this is Lagrange or one like this, right? Now we use a two-way key. This is called two-way key. We will have three terminals. This is K. Name it K1. This is K2, and one will be the common terminal. CT, common terminal. This common terminal is connected to what? Galvano. And galvano to job. Very easy. E1 is connected to K1, E2 is connected to K2, and the middle one is the common terminal. Common terminal is connected to galvano. This is the CKT. Remember, circuit diagram is must. Comparison of EMF of two cells. Right? Once the circuit is set up, again and again we have to check the continuity. Remember, this is the key factor in while doing practical. That continuity should be there, otherwise everything is null and void. System is same, how to get the continuity, right? We have to repeat the same process. If I am tapping at A, gives a deflection in a particular direction. So while tapping at B, it must give a deflection in opposite direction. This we have to establish, otherwise there is no use of wasting your time on the practical. Right? Now how to compare? A very simple concept. Case 1. If K1 is on and K2 is off, what does it mean? I simply take it out and apply K1 here and take K2 knob is taken out. So what will happen? So E1 will be in the circuit and E2 will be taken out or out of circuit. Just like your first experiment, it has become like this, right? Let L1 be the null point position. Then according to potentiometer principle, what will happen? E1 will become directly proportional to L1, or I could say E1 equal to KL1. This will be the first equation. Right? Now case 2. If K2 is on, K2 is on and K1 is off. So what will happen? E2 will be in the circuit and E1 will be out of circuit. Let L2 be the position of null point. Then same according to principle of potentiometer, what will happen? This E2 will become directly proportional to L2 and you will get E2 equal to KL2. This is the second equation. Right? What our aim? It was just to compare the EMF. So dividing equation 1 and 2, what you will get? E1 by E2 will come out to be L1 by L2. Simple. Right? That's how we do it in practical also. Right? This is the comparison of EMF by using potentiometer. Right? So what we do, how we perform in your lab, that is a bit different. Right? What we do, with the help of rheostat, we set a particular current. Right? In first, for a particular value of RS, suppose L1 is 502 and L2 is 467, right? For particular value of RH. Then E1 by E2 will be what? 502 by 461. We will find out a value. Just divide 502 by 467. In second part of the experiment, we value the value of RH. With the help of this knob, just sliding it. Right? Suppose L1 comes out to be 491 and L2 comes out to be 452. Right? Then again we will calculate E1 by E2. Ratio will come out almost same. Here we do not use the mean method. Third, vary the value of RH. Let L1 becomes 532, L2 495. In this case, again calculate E1 by E2 as 532 by 495. It will give a particular value. How much it is? In first case, E1 by I2 comes out to be 1.07:1. In second case, it is 1.082:1. In third case, it is 1.07:1. So we are getting two repeated values. So without taking any mean, remember, E1 is to E2 will become 1.07:1. That will be our final result. That's how we perform in our practical lab. Right? This is to compare. Now, second experiment is to find out the value of internal resistance. How to do that? Value of internal resistance of an unknown cell. This is for internal resistance. First of all, what is internal resistance? Remember, it is the resistance provided by the solution of the cell which we are using will also provide a resistance, that is internal resistance, and that internal resistance depends on what? The type of electrolyte we are using, the electrodes, the spacing between the electrodes and all these things, right, as we have read. So how to find out internal resistance? First we will deal it mathematically. Mathematically what we have? E is the total EMF of the circuit, and it says that it is nothing but I R plus R. V, the potential difference across R and external resistance, so V is nothing but I into R. So what will be E via V? It will be I R plus R divided by I into R. Y is cancelled, we left with 1 plus R via R. This is the theoretical part, we got it. E via V is nothing but 1 plus R via R. Now how to calculate practically the value of E and V? That's why we are using this potentiometer. We set up the circuit like this again, right? And unknown cell, Lachlancy or Denia, whatever you have, is applied, and RV is applied, key is there, and it is connected to galvanosome. Case 1, when the key is open, what will happen? The RV will be out of circuit and cell will be in the circuit. Right? So what will happen when it is out of circuit means what? It is our first part of our experiment, right? So before starting, again you have to check the continuity. Remember, this is very much important, very much necessary. Continuity you have to check. Double side deflection should be there. Let L1 be the null point position. With the help of jockey, we will try to find out null point AC. So, according to principle of potentiometer, what will happen? You will get E equal to K L1. This is the first part of the experiment. Right? That will give you the EMF of the cell. Now, we want to calculate the potential difference across any applied value. For that, what we do, case 2, when key is closed, means now it is applied here, the R will be in the circuit instead of out of circuit. Now it will be in the circuit, right? And we will try to find out the null point position. Let L2 be the null point. Position for a particular value of R. Remember, particular value of R. What does it mean? I am having RV. RV means a variable resistor, right? Consists of a very large number of resistors in it. So we can apply 1 ohm, 2 ohm, 3 ohm, whatever is required. For a particular value of R, let L2 be the null point position. Then in this condition, the potential difference across this R will be directly proportional to L2 or what our principle says, and it gives you V equal to KL2. right? This is the practical value. So what if I divide this, and yes, so practically we will get E via V is equal to K L1 via K L2. This is the practical value, and theoretically E via V is 1 plus R by R. This is the first equation. Now comparing 1 and 2, what we will get? 1 plus R via R equal to L1 via L2. R via R will be L1 upon L2 minus 1. So what will the value of small r? Will be R L1 upon L2 minus 1. That's how we will get the unknown resistance of an unknown cell, internal resistance of an unknown cell. How to do it practically while taking the reading? So what we will do, for example, I am having it R equal to 3 ohm, right? Let L2 be 267 centimeter, right? L1 will remain same, let L1 be 512 centimeter, because R11 we have to consider only once. Then what will be small r? According to our formula, R into 512 by 267 minus 1, instead of R we can apply 3. And we can very easily calculate the internal resistance. See, this is first part. Second observation, for R is equal to 5 ohm. Third observation, for R is equal to 7 ohm, or 1, 2, 3, whatever you want, you can calculate R. Same way, L1 will remain same and L2 will vary, right? And what will be the internal resistance? R will become R1 plus R2 plus R3 divided by 3. That much ohm will be the internal. It's a very simple experiment. That's how we do potentiometer, right? Now the basic question, why it is needed? We were having voltmeter, very easily one can calculate the EMF, right? And compare it. What is the superiority of potentiometer? Most of the time they do ask. Superiority of a potentiometer over a voltmeter. When we are having voltmeter, why we are using a potentiometer? Right? This is a very popular question. So what happened? If you do remember, for an ideal voltmeter, what we have? Resistance tends towards infinity, right? Practically, it is not possible to have such voltmeter. Then what to do? This problem is resolved in potentiometer. In potentiometer, what happens? At null point position, null point position, what happens? I becomes 0, right? No current flows through the circuit and I becomes 0. According to Ohm's law, what we have? V equal to IR. If I say R will be what? V by R. V by 0. That gives you infinity. Right? Means at null point position. The potentiometer behaves just like an ideal voltmeter. This is the main superiority of potentiometer over the voltmeter. And one more thing, that it is very sensitive. Potentiometer having a large length means it is very sensitive also. This is all about potentiometer, right? Later on we will deal with the numerical of this particular part, which is very important. You can't ignore that part. That's we will have in the next lecture. Thank you and have a nice day. Keep on subscribing our channel if you think that it is of some metal for you. Thank you.